discussion using the outline, but I'll make it very brief. And I'll use a hybrid approach, both practical and theoretical, because it's a practical thing we're talking about. We're talking about smarter environment with Internet of Things. Okay, and there are a few concepts that we actually need to understand and plow into these things and see how we can move forward. So we'll make a few definitions, look at the architecture of the Internet of Things. There are several architectures, and then we'll throw ourselves a challenge. Is it best to adopt existing architectures? Do we build things? I'm coming from the university environment, and we like to try our hands on a lot of things. I'll talk about that too. Then we'll look at the generic, structure of smart environments. We'll look at practical tools and protocols on how we can actually build smart environment using IoT-based technologies. And then we'll move from there. Then we'll look at the Nigerian situation. Where are we? How far have we come? And where are we going? Do we have things in place for what we actually plan to do? Now, in simple words, talking about a smart environment, we're talking about smart objects. We're talking about smart people. How are they smart? Because they talk to themselves without human interaction or human-to-machine interaction, okay? So I'm running late for a conference like this, and my car can actually send a message telling them, please, I'm running a bit late, okay? As I'm going back to my hotel room, I don't need to get back to put on my heater. I can put it on from here using my phone. You can do a lot of things easily, but we still have a long way to go. It's already working in several places, and we can actually bring it home. So talking about a smart environment, we're actually talking about several things. That's what we're talking about, Internet of Things. Things could be objects in our environment. Your car is a thing, Things could be anything, wearables, something you wear, but that has a tag, that has both a name and an identifier. These are things. And these are things we use every day. So the important underlying concept about Internet of Things and smart environment is the fact that we want to be able to address things. We want to be able to uniquely talk to things, and these things can talk to themselves without even us, stopping or interrupting these things. That's the whole essence about having smart cities, smart environment, and smart things. Now, if you look at the literature, there are several architectures for Internet of Things. The basic is the 3-tier one we know. At the base, you have the perception layer, and then you have the network layer, and then you have an application layer. Please don't confuse this with your popular network, 5 network ISO architecture, all right? But what are we talking about? Now, there are several of them. The first one I said is the basic 3-tier architecture. But for the Nigerian situation, I prefer the last one, the 5-layer architecture. And we're going to look at them very briefly. I won't waste your time. And then apart from the architecture, because from what I gathered, today we're supposed to be launching some smart initiative in our country, all right? We need to actually build things from the base. We need to understand what we need to put in place. How ready are we for a smart environment, okay? So we need to understand building architectures from scratch, building the protocols, or reusing protocols, but knowing how they interface, because we're talking about heterogeneous systems. We're talking about things that are all built differently, different machines, different things. So there's a lot involved, much more than just meets the eye. So this particular architecture, you have the objects or perception layer at the base, and that's why we have the sensors and the actuators. What are sensors? Sensors are just tools, things that actually sense from your environment. They pick the natural things like humidity, like heat, like movement, like motions. We can have both active and passive sensors. We actually do a bit of practicals in the lab with our students. I'll get to that using Arduino board and a few things like that. Okay, so that's what sensors are. So we want to be able to sense things naturally from our environment. So my fridge can actually place order because I'm running out of grocery. So it just checks, I'm running out of milk, and then it checks, okay, we need to actually place order for more milk, and two days after, I have milk at my doorstep and I pick it up. So that's what we're talking about. So we have that at the base. And this is where all the big data we're dealing with. I like a question that someone asked. a lot of data. I ran into problems, a few weeks ago. I'm working on something, we're supposed to be presenting it somewhere in Scotland, and everyone is excited about it, but where is the big data? Where is so much data? I'm not talking about 10,000, 20,000, several millions of data from different sensor networks, from different applications. So you find out that all of this data we gather are actually gathered at the perception layer, at this first layer. Now after that, we have an in-between layer, the object abstraction layer, that actually moves what we have gathered from that level to the next layer for processing. And many times we use RFID, we're using radio frequency IDs. Now, we may be familiar with radio frequency IDs, so we have tags, and then we have systems, and they are not like the normal ones we know that we use in our supermarket and all of that, because these ones, you don't need to be in line of sight. You can even scan something that is in a pack, okay? You can read data from afar, so that's why you have a lot of those technologies. So at this layer, we actually do what transfer data produced at the initial layer, the perception layer, and then we move it forward to the service management layer. The service management layer basically is for pairing. Like I said, every IoT device must be named and must be identified. So their names, their identifications, and of course you need to be able to pair, demand, what does the end user want? What object am I getting this from? So this is done at this next layer. And then of course we have the application layer where a lot of our young people will come in with time, developing a lot of applications. We have several things happening in different parts of the world, okay? So we have different things in agriculture, in different areas. So these applications can be built at that point. We're talking about a smart home, we're talking about a smart community, smart agriculture, smart buildings, smart everything. These are different applications that can be built at that level, okay? And then we have the business layer. For me, this is about the most important part. We've gathered a lot of data over the years. What have we done with all the data that we have gathered? We have a lot of things we've done, a lot of initiatives that have begun. What have we done with all this data? So we need intelligent tools. We're doing a bit of little work here and there, not so much. We use Hadoop, we use R, to do a bit of analytics in my institution and all of that. So we need to be able to speak to data. We need to be able to make data learn. Reinforcement learning, supervised learning, not just teaching them on the board to the students, but putting them to practice, show them data sets, and run these analytics, and let them know that you could actually take a lot of decisions presently and things for the future from this data. So that's what happens at the business layer. So all these things have to be put in place. So we can't talk about the smart city if we have not addressed the issue of what we have. What architecture are we going to be running? Is it going to be proprietary, like you said? Is it? I am a fan of open source, okay, because everyone is making it better every day. So these are issues that we actually look at when we're talking about smart environment. Now, apart from that, we have different elements in every IoT. We've talked about identification, sensing, communication. You have to move things, from one place to another. That's where the communication comes. Computation, I just mentioned that. Okay, for us, the little bit of work we do, Arduino, Raspberry Pi, these are things, that we can actually use. So sorry, I wasn't using this. Now I know, my voice is better now. Okay, so this is where we actually do some computation, and then we deliver them as services. We're talking about service-oriented architectures. We're deploying web services now. We're moving beyond just building applications that are platform independent. We're talking machine to machine, okay? So we're moving to deploying these services and adding meaning to whatever we're doing, building ontologies and doing all of that. So this is captured in the IoT elements. Now, so what is a smart environment? We're talking about smarter environment. All I've been trying to do is trying to make us understand a bit of what this Internet of Things is all about. We want to create an internet of everything, of things, everything, your handbag, as long as it has an identification, your arm, medical tools, wearable, your clothes, your eyeglasses, your oven, everything. So that's what we're talking about, Internet of Things, where everything can actually communicate one to another. So what is a smart environment? Cook defines it like an environment that, where all kinds of smart devices are continuously working to make users' lives more comfortable. That's actually the essence of a smart environment. Now, so in all of this, what do we need to build smart environment? We need things, I've talked about architectural things. We need things at different levels, okay? So, of course, we have the physical world. We want to merge the physical world with the information world, okay? And we want to run a lot of things through embedded systems. What are embedded systems? Systems that apparently don't look like computers, but they're actually computers. So you walk into Bolton White, where I stayed, and the door opens. It's actually, it's an embedded system, okay? And they actually do specific jobs, not like your computer that you can program in any language to do different things. They are tailored to do specific things. Those are embedded systems, and they can actually be embedded into appliances, okay? So that's what we have in a smart environment. So if you take a look at that diagram there, you see several parts of our economy, coming together. You have smart health. Okay, I had a colleague of mine who developed a few things that elderly people strap on their arms, and it monitors their heartbeat, it monitors a few things about them and sends them to the doctor. So you don't need to, my supervisor was telling me there's a place she goes once in a while. You don't need to go every day to, I'm not saying that we're not going to be going to hospitals, but there are little things that you could actually find out for yourself, or little data about you that can actually go through the wire. But then, like you said, security, privacy is a big thing when we're talking about building smart cities, and we'll talk about that in a moment. So we have smart government, we have smart education, we have where we can actually do things easier, do things faster, and actually get a lot of intelligence and thinking and decision-making processes out of all the data we have gathered over the years. Now, averagely, for countries that are already, operating smart, you find out that healthcare is the biggest thing. So we're going to go back to our universities and find out that health informatics, anything that has to do with, don't say I'm a computer scientist, most of the breakthroughs we've had, it's in the area of health. So health is a big thing. People want to live long. Agriculture is also a big thing. People want to have good food to eat. I have an undergraduate student. He's working on an automatic watering system for plants. It comes from the village. So how can I have my plants watered? I don't need to get, to the farm to do that. We're starting small, but little drops of water is what makes the mighty ocean, okay? So these are areas that we're already moving, and of course, smart communities have come to stay. So the earlier we begin to plan for them, the better it is for us. Now, we're told that by 2020, we'll have 50 billion devices on the internet. Right now, we're still in 2017, and the prediction is almost, true. This was done in 2015 by a very active group on this. This from Deloitte University Press. So we're going to have more devices come up on the Internet of Things. Now, let's narrow into the Nigerian situation. If we really want to build, a smart city or a smart environment, where does it start? I guess it starts from you being a smart person, okay? And then it starts from building a smart home. So architecturally, we actually have the home domain, the community domain, and the service domain. And these three domains must actually be put in place. So you want to build a smart city, then people must have smart homes. They must have things that are already talking together. That's why we're doing the little practicals to see, how can my fridge, respond to my send emails? How can this happen? How can this happen? So it starts from the home. So every home has connected devices. And all these devices are actually, so you have a home network, and all these devices, at the end of the day, they are put into a gateway. So everything is connected, and there is some point, the home gateway. Now the gateway sits in between your home and the community. So let's say that in Star Village, where I work, University Star Village, every home is connected. Then within Star Village, of course, every home will have a gateway where all your devices that talk to themselves actually send data to the gateway. And then that gateway will now interface with the immediate community, whatever community. These have to be defined. I'm going to talk about that, the business part of creating smart cities. You don't just get up and create a smart city. People already had ideals, they already had things they were doing. So you have to define what goals, what are we actually doing if we're building a smart city. So we have a home network, and we talked about that, and we use simple techniques to connect our devices together. And then from the home network, we actually go to the community domain. And then at the community domain, we have what we call a community center. Now, the community center actually gathers all the information or inputs from the individual home gateways. And these have to be put in place, these have to be built, these have to be automated, these have to be engineered, okay? So all these go together, and then finally we have a call center. Now the call center is supposed to now be what reports to the government. So it could be run by the police or the security or anything, but it's also connected to both the community and to the home gateways. That's the architecture, the basic architecture. Now, the small things we do, where we are starting from, that's an Arduino board. And then, of course, we have smart objects. I said sensors, potentiometer, hydrometer, whatever. It depends on what you want to sense from your environment. Now, most of these boards are actually built just for little practical and small scale Internet of Things that we actually do, okay? So you can actually have that. Now, if you have on this other side, that's a breadboard. The breadboard is actually to help you wire. And if you look carefully at the breadboard, it's demarcated into two. On this side, you see things that are connected in several rows. If you count those rows, there are rows of 5. So if you want to connect two devices together, you put them on the same row. You're connecting them. And this other side is basically for ground, okay? You connect back to the board. And then you can have an actuator. It could be a motor, it could be any kind of motor, just something that gives feedback back to the environment. So it could actually be your mobile device, it could be anything. But you have something that senses, and please don't forget, sensors, when they sense things from the environment, they don't get them in digital form. So there has to be conversion in between, and all of these things are programmed, of course. So there has to be transformation of whatever data is gathered, and then it's put in digital form, and it's transmitted over the wire, and then it's converted back at the other end, because the actuators most times will also have to relate to humans so that they understand what data they are looking for. So this is just little things. So you can do a little experiment, connect a potentiometer and a motor and see if it moves. Connect your lights. Can I actually light my house from this motor? Little practical things, they are not difficult things. From here we build to the bigger things that we actually do. So you need to understand the basic practical things. I mean, for the academics, for students that actually want to be involved. Because there are a lot of algorithms, there are a lot of protocols that are already working for different people. But you find out that even if we need to integrate them, you need to understand how these things were built from scratch. So it is actually important to understand them. There are a myriad of protocols for the Internet of Things, and they are put in layers just like we have the network layer. So you have different protocols working at different layers. We mentioned, the RFID working at the physical layer and the data link layer, TCP, all the ones we know, and we have recent ones like the constrained, protocol, application protocol for power, because power is a big thing in dealing with smart cities. You're going to be talking to systems almost 24/7, and they have to stay on, they have to be alive. So the power consumption has to be little. So these are protocols that we actually use when we're building this. Now, what is the process for building smart environments? It's a 5-point process. You can add, you can subtract from, but first we have to create. Second, we have to communicate. Number 3, we have to aggregate this data that we're getting from different sources and at different times. And it's not just enough to aggregate them, put them in several servers, be sure that they are saved, and then we have to analyze. How do we make the life of the people in this environment better? How can I get an elderly woman to actually use things in her house without having to inconvenience her kids that don't have to live with her all her life? How do I get disabled people to still live lives as if they are living normal lives? We do all of that. Then we have the analysis, and then the act and the initiation. That's just showing that. Now, I'm rounding up in a few minutes. Now, for the Nigerian situation, what do we need to do? We need to gather major stakeholders and decide on the goals of smart cities. We need to put our policies on ground. We need to actually categorize government agencies and know their sub-goals. We actually need to create context profiles. Every individual should have a context profile, and we should actually create dictionaries of these profiles. We need to streamline this information, how they go through the gateways, and we need to ensure that they actually are channeled right. Now, we've said a few things about Nigeria so far. I'll just get to the point. There are a few things. Uber transport, I don't know how many of us have used it. That's e-commerce, that's IoT, a bit of IoT. Jumia tracks tools, that's a bit of IoT. We already have some appliances, wearables, ovens that are smart. That's coming, a few things that we already have in the market. But our concerns are many, and some of them are this. How efficient is our cloud service? Remember, sometime in 2006, we launched the Galaxy Backbone. It's working, but we need to make it work better so that everyone can actually have access and have all the data that we need. How are our coverages? We need CCTV cameras at strategic places. Have we put those things in place? How affordable is the internet we're using? We're talking about putting phones, putting TVs, putting everything, and this is internet. How affordable can the local man afford, the internet? These are a lot of, concerns that we actually have. The way forward, we've actually said that we can put Wi-Fi connections on networks in several places. We can, begin to teach these things and make it practical, create an awareness of the fact that, look, it's not just word of mouth, but these are things that are coming with us to stay, okay? And then we can create research groups, like we said, to handle a lot of things in this area. Thank you very much.